Hello everyone, welcome to CSE Core Concepts. In my video of series Data Structures, here now we are discussing about graphs, and in my last video I have discussed about the introduction of graphs and some of its important parameters we have discussed. Now in this video I am going to discuss about the traversals in a graph. There are two ways of traversing through the nodes in the graph. One is the breadth first search and second is the depth first search. In my next video, I am going to discuss about depth first search. Meanwhile, here in breadth first search, I am going to discuss it with the help of a suitable example. Breadth first search is also called as a level ordered traversal, and it helps to find out the shortest distance between some starting node. So out of all the nodes in the graph given, you select one of the node as your starting node, and from that node you can find out the shortest distance from that node to the remaining nodes of the graph, or you can simply traverse through the graph. In the case of breadth first search, while traversing through the nodes, we are going to use the linear data type structure, that is a queue, while processing the nodes and keeping them one after the other. Now, let us consider this graph having 5 nodes. It is an undirected graph and non-weighted graph. No weights are given on the edges. Now let us say, for example, we have to first select, either you could be given in the problem what is your source node, or in this case when it is not given, say we are told that let us consider P as our source node. Now if I consider P as my source node, then I want to traverse through the various nodes starting from P. Now the steps which I need to follow is that, first of all, let me tell you, we are going to use here two data structure. One is a queue and one is a simple array in which we are going to put the elements, or you can use both of them as queues. No problem in that, right? Now here in this case what we will do is, one queue is the one which we are going to use to process the nodes. And the second queue which we are going to use is the visited queue. It will keep a track of the order of the nodes in which they were visited. Understood? So first node you are going to pick up. So from where we are going to start? We are going to obviously start from the source vertex, that is P. So I am going to put P in the queue, right? Assuming that none of them has been visited right now. So in P, is visited, okay, but it will come later. Fine. Just for the illustration purpose, I am showing you with the red color that this element will be removed. Now, since P is the only element, it is the front of the queue. Fine. Now, first of all, we are going to enqueue in the queue array, right? Okay, so I have added P in the queue array. Now I have to dequeue P, that means to say that I have visited P. To represent that I have visited P, I will keep it in the visited queue. Understood? Now before keeping it in the visited queue, I am going to add its non-visited neighbors. That is, the adjacent nodes of P will be added to the queue which have not been visited. Understood? And then I am going to process each neighbor one by one in the same way. I will take that node, add its neighbors, unvisited neighbors, and put it in the visited queue, and so on. So let us start with the first element, that is P, and let us check who are its non-visited neighbors. That is very important. The neighbors which have already been visited, we are not going to traverse them again. So I have two non-visited neighbors here of P, that is Q and R. Understood? Now Q and R both are not visited yet because this is just the starting. So we will put Q and R in the queue. Now Q follows what structure? First in, first out. So first I will put Q, then I will put R, and who will be removed first? P will be removed first. So when P will be removed from this queue, and it will be kept in the visited queue because it has already been traversed. So when P is being removed, who becomes the front of the queue? Q, right? Alphabet Q will become the front. Fine. Now it's time to process the next front. So this process will get repeated until all the nodes are being traversed, right? So now who are the neighbors of Q? Let's see first of all. Q's neighbors are P, R and S. Now as far as P is concerned, P is already been processed. It has already reached the visited queue. So we are not going to add P again. R is already in the queue added because it was also a neighbor of P. S, yes, S is the neighbor who has not yet been visited. So we are going to add S to the queue. Now it's time to dequeue, right? Whom will I dequeue? The front element. Who is the front element? Alphabet Q is my front element. So I will dequeue Q from this and I will add it to the visited queue, right? So now who will become my front? R will become my front. Now for the element R, I am going to first find out its neighbors. Who are the neighbors of R? Q and T. Now Q is already been processed, so I cannot add again Q. T is an unvisited neighbor, yet we have not visited T. So T will simply be added to the queue. And now I have to dequeue R. So when I will be dequeuing R, I will put it in the visited list. Done. So who will become my front now? S will become my front. Now when S becomes my front, let us find out who are its neighbors. So the neighbors of S are Q and T. Out of them, Q is already been processed and T has already been added in the queue. So I don't have any other element to be added. It's fine. Who is the front element? It's time to dequeue now. So who is the front element? S. So S will be removed from here and it will be added to the visited node. Now who becomes my front element? T. Who are the neighbors of T? Let's go and check out first. S and R. Both have been processed. S and R both have been processed. So I have nothing else remaining here to be added. So I am going to simply dequeue T from this and mark it as visited. So what is the order of traversal here? A level order, right? P, Q, R, S, T. Okay, so all the nodes have been traversed. So I will stop my algorithm here. So one thing which you need to keep in mind here is that you are going to use the queue type of a data structure in order to perform the traversal in case of breadth first search. And of course, queue follows a first in, first out order. So in that way, you are going to traverse. In my next video, I am going to discuss about depth first search. So stay tuned for more such informative videos. And please press the like button if you like my video, and don't forget to share and subscribe to CSE Core Concepts. Thank you.